In this tutorial, we're going to be talking about nullable types. So what are nullable types? In our last tutorial, I highly recommend you watch that, where we talked about the keyword null. I briefly mentioned that reference type objects like lists and objects and things, if you don't initialize them, they get the default value of null, which is a null pointer. However, for value types, these tend to have the default value of 0. But if we try to use the keyword null with a value type object, it's not going to work because we can't really give it a reference pointer because it's a value type. It stores a value like 3456, for example, or true. It actually stores the value of a value type in the stack area of memory. So what is a nullable type? Well, a nullable value type like these is an instance where a value type can actually store null. So why would we want to do that, and how do we do that? So for example, when I tried to set this as null before, it didn't work. However, if I add a question mark after the data type right here, you can see that error has gone away, it's been resolved. So what is going on here? Well, to turn a value type object like an int, a bool, a character, simple types, if we add a question mark to the end right here, then this represents a nullable value type. So now this variable is a nullable value type. So now it can take a value, or it can take the keyword null. So why might you want to do this? What is the point of this? Well, imagine you have, for example, a class register. You have a bit of software, and it marks the attendance for students in your classroom. Now, let's say it has a database attached, and inside the database you have all the names of the students, first name, last name, all of that good stuff. And then you have a boolean in the database, and the value in the database would be called something like is in attendance. Now, if the children haven't even arrived to the classroom yet, then we don't know if they're in attendance. So we can't really say true because we don't know. We haven't actually done the register. We haven't actually checked to see which students showed up to the class. But if I store the value of false in the database by default, then I can kind of just change this to true if they are present in the class. Then, well, I mean, this is saying they're not in attendance, but really I'm not sure yet because they haven't arrived to the classroom. So in cases like this, you might want a third value for a boolean, for example. You might want null if we don't know yet. And if the student arrives and they're here, we can say true. But if the student is absent, maybe they're sick, we can say false. So in cases like this, we might want a third value. And a keyword like null represents something like a default value, like not knowing the outcome yet, or something like that. So if we're not sure if they're here yet, then we could use something like a nullable data type here, which is the boolean, and we don't know if they're in the class, so we can just initialize it to null. And in the database for this, maybe this field would be empty, or it might even say null, it doesn't matter. But the point is, when the children start arriving into the class, then we can set this to true and false. And that's kind of the principle behind it. It gives you a third option, for example. And again, this is similar with integers. We can set those to null if we don't have a specific value for whatever number we want to model. So anything like that, there's lots of different reasons why we might want a nullable value type. So when working with nullable value types, by just adding a little question mark after the type right here, it does give you a few more options. And why is that? Well, let's take this variable here for instance. This is nullable. So now if I put a dot afterwards, I have access to a couple of properties here. If I remove that question mark, so I have a simple boolean, you can see those properties have disappeared. So what is going on here? Why do I have these extra properties for a nullable value type? That's because behind the scenes, it's a structure very similar to a class. So rather than having a simple boolean like before, where we can just have a boolean and then use it, we can output it to the window, we can pass it to a method, all that good stuff. Now we have a structure. Think of it like a class. And what the class does in this case, it just exposes two properties. One is the actual value for our nullable data type. So this now is in attendance.value would be the same as having a non-nullable data type and using that. So we can use the value property here to get the underlying value, which would be true or false, for example. And it has one other thing as well called has value. Now we can actually use this Boolean property here to work out if it has a value. So what you would normally do for something like this is have an if statement and say, okay, does it have a value? Okay, it does have a value. Therefore, we can access the value and print it to the console, for example. So something like this. And doing things this way and having these properties available to us avoids things like null reference exceptions or just even checking for null, for example. So this is why it has these properties available. We want to check it has a value and then we can utilize the value. So this is why these are quite useful. And this is why when you define a nullable data type, it exposes these extra properties for you to make use of because it gives you this third option, which is null. And if you are wondering if you have a nullable value type object and you don't initialize it, then the default value would be null. So not 0 in this case. Because it's nullable, the default value is null. So in a nutshell, that is an example of nullable types in C#.